All right. Okay, so as we're waiting for people to come on in, please go in and double check that we have the correct seat for you on the seating chart. This is really important. And you know, there's a little scroll bar at the bottom to get to the other seats. So please make sure that you have put in your name. Now, I think a few people ran into an issue because when you type into any kind of a spreadsheet like this, if you want it to save, you have to leave that cell. So you're typing your name into one cell, one little box. So if you're on a computer, you hit enter, or if you're on an iPad or your phone, you just click a different cell, click like a white cell, and then it automatically saves it. Okay, so I think a few people didn't know that. And so last time they typed it in and just closed their window and it didn't save. So please go ahead and do that. You're also going to need a calculator today, and you should pull up on your computer your best friend, the exam resources. Should be your best friend. You should have it for every class. You should have it for all your homeworks. Y'all know what I'm talking about, right? You know where to get it on Moodle? If I go to Moodle and I come to exam 1, my resources available on exam 1 are going to be there. Oh, absolutely. If you didn't bring your calculator today, just use your phone, no problem. But just try to always bring your phone. Try to always bring your calculator so that you have the calculator that you're going to use on the exam. But always do something, you know, whatever you have. You just got to make sure to mute your audio output and mute your audio input as well if you want to join on Zoom. Okay. And I started the iClicker with this attendance question. I think we have more than 31 people in class, so everybody try to, make sure, double check that you are in the 5T section on iClicker. I had a few people who joined 4T, and I had a few people who joined my 400 level biochemistry. I don't think you really want to be in that class. So make sure on your iClicker it says Chem 109 5T because you are in 5T. Okay. And it should be AA if you have a handheld. It should be AA or A. Does it tell you if you've answered or not?
No. It doesn't say
it doesn't say if it got it or not. I don't know, like I don't know what the readout is on those. But now, if you've purchased a handheld, that means you should automatically get 5 years subscription to the one on your phone. So if you want to use your phone, you can use your phone because it will take a picture. I don't know why it just did that on my screen, but it will take a picture of my screen when I put the question up, and that picture of that question will show up on your phone. So the only rule is whatever device you start using at the beginning of class, you have to use that same device throughout the entire class setting, right? If on Tuesday you come back and you used your handheld today, you want to use your phone on Tuesday, go for it. And then on Thursday, you want to use the handheld iClicker, go for it. It's all linked to your account, but you can only use one per session, if that makes sense. Yeah. Okay. I don't know why, but right now this is the question that we are answering. Okay, so y'all ready? Okay, got to start with the best thing first, right? So what do you call a sleeping Dinosaur. A dinosaur. Kind of messed it up there. It's bad that I can't even tell a fourth grade level joke. I'm trying to think. Okay, we had some other good ones because I messed that one up. Why did the little girl bring a ladder to school? Because she wanted to go to high school. All right. Okay, so looks like we have about 47 people today. If you have not checked in, check in. And then, as I was saying, let's see if I go forward one. Yes, ma'am.
Since it doesn't tell us, like, could you tell us if it went through?
I don't know. I can look at the roster. I can see if y'all checked in. But I can't tell if an individual person's from here has received. But if there's probably about 47 in here. So it looks like everybody's is working. Even the ones, now these, if this is your number down here, you need to associate this with your name. So if one of these numbers is your handheld eye clicker, that means you need to associate your handheld eye clicker number with your clicker account. Okay. All right. Let me go back to the poll. All right. So I have some things that I want to remind you. Number one is go and check the seating chart. Please, please, please go and check the seating chart and make sure that you have your name in the right place on this seating chart. Okay, everybody. Okay. All right, let's see. The other thing, some people were having some issues accessing the homework. Like you have a homework assignment due tomorrow, right? Tomorrow at midnight. What is due tomorrow at midnight? Mini homework A, which is just like learning how to use the MyLab and mastering program, right? So some people were having an issue where they would follow all the steps and they get to the Pearson site and then it would be like blank. A lot of times the problem is that you're using Safari. So anytime you use anything that has to do with Moodle, use Chrome. Like from here on out, if you're doing a school thing, use Chrome. Because all of the programs, all that kind of stuff were designed to run with Chrome. So go ahead and use Chrome. Let's see. Then you have a homework due on, we have mini homework A due on Friday. Then what? Homework 1, chapter 1 due Monday, which we actually didn't finish chapter 1 in the 4T section. So I'm betting we won't finish it here. So I'll probably end up moving that back, but stay tuned. Then what's due on Wednesday? Mini homework B, which is updating your profile picture and the little form, right? The course agreement form. Okay. All right. So we'll see how we do. All right. So first thing, get your eye clickers ready. Y'all ready? Now, I'm going to ask you a question. This is not a question for your neighbor. This is a question for you, but it's like an open book question. Any of the resources that you have in front of you, like your handout that you printed out, the work, your notebook, your whatever, use it, okay? I'm going to give you 1 minute to answer the question, and then I'm going to close the poll. Because this is something that we talked about in the last class, or you should have watched in the video, okay? So let me make this big, full screen. Okay, so here's our question. Which of the following is not a pure substance? Steam, ammonia, gasoline, or iodine crystals? So we had 47, so I'm gonna start it. And there's a little countdown timer for 1 minute. So this is your answer. Don't look at anybody else's. This is just you. And I'll give you a 10-second warning. Don't leave it blank. Okay, 10 seconds. Don't leave it blank. I'm looking for the number 47 because that's how many we had present today. We're at 1 minute, but we still have a few more who need to put an answer. Please put an answer. In the future, I will cut it off at 1 minute. I'm trying to be nice. Really trying. We want 47. Y'all please answer. Okay, I'm gonna cut it off in 5 seconds. So at 1:25, I'm cutting it off. What?
I don't know if I answered.
Now you should know if you answered or not, because like the poll's over, so it should. I don't know. Okay. Now, we're gonna run things a little differently the second go round. I'm gonna give you the same questions, the exact same question. I'm not telling you the answer. But now I'm telling you, you may talk to your neighbors. Please put your mask over your nose and your mouth. You can talk to your neighbors, any neighbors, I don't care. Have a conversation. You have a minute to come up with a second answer. So I'm gonna open the poll again, and you're gonna submit a second answer in the next minute. Okay? Go. Turn around, talk. Thing's not connected. Try to change your. Okay, it's been more than a minute. Been more than a minute. Please put an answer if you have not put an answer. Please put an answer. I'm going to tell y'all some other good news too after this. I'm just full of good news today. Please make sure you've answered. I'm going to cut it off at 1:30. Okay, so let's look at our answers. So we have 84% picked gasoline. Very good. So this is when you were having the conversation. When you didn't have the conversation, only 61% picked gasoline. So are your neighbors smart? Are you smart? Yes, talk to them. All right, so let's talk about it together. What is steam? It's water. What's a pure substance? Whoa. An element or compound. What's water? A compound. It's H2O. It's more than one square on the periodic table. So this is a pure substance. That's a check. Ammonia. It's not an element. It's a compound. It's NH3. So it's a compound. So it must be a pure substance. Iodine crystals. Iodine's on the periodic table, right? Is there anything else? Doesn't say. No. So it's really just I2. And that's a pure substance. You don't have to know the chemical formulas, but you have to know, is it a pure substance or not? Okay, so how about gasoline? What did we talk about yesterday? I always do that. I'm just gonna say yesterday and you'll know exactly what I mean, right? Okay, so what did we talk about the last time we were in here? We don't wanna put what in our boats? Ethanol. So is gasoline a pure substance? No. No, it's not. It's actually more than just ethanol and gasoline. Gasoline is really a mixture of all kinds of different hydrocarbons, right? It's all those dead dinosaurs that have turned into gasoline, right? So you just put dead dinosaurs in your car. Definitely not a pure substance. So this would be what? A mixture, right? A mixture. Okay. All right. So let's try again. You ready? Now that first it's by yourself. Then I'm going to give you a chance to answer it. But here's the thing. Remember we said this is worth 100 points, like an exam, right? But it's only a couple every day, right? It's a few. What do you have to get to make an A on a regular assignment? 90% or above. What do you have to make on an iClicker? A 70% is an A. So I incorporated a 20% curve. I incorporated that 20% curve for a couple of things, couple of reasons, really 3 reasons. Number one, you're not always going to know the right answer, and it's okay. We're still learning, right? So I'm giving you that little cushion. Number 2, you might be absent. It happens. I don't give makeup points for iClicker. And number 3, you can have technical problems. It's okay. 70% is an A. All right. So don't freak out. There'll be more questions. It'll be okay. All right. Okay. So let's try one more. Oh, I gave you the answer there. Okay. All right. Which of the following substances can be classified as a homogeneous mixture? Salt water, oil and vinegar, hydrogen, or water? 1 minute. It's on the wrong. Should be on AA, but I don't know how to. I don't use these, so I don't know how to. Hold the power button. And then just, oh, there you go. Thank y'all. So did you not hold down the power button? And when you hold down the power button, then you can type in the frequency. Or is your app working? AA, should be AA. Hold it down and it should give you a box and you type it in. Okay, all right. So we're over a minute. So everybody put something in? Okay, so I'm gonna stop it. Now we're gonna run the same question, but guess what you get to do? Turn and talk to your neighbors. Okay, turn and talk to your neighbors. Please use your masks right now, especially while you're talking. Please use those masks. %. 70%. That's all we're shooting for. I try to be understanding. Try. Make sure you check in on that second answer. You got about 10 seconds. So make sure you check in on that second answer. Okay. Everybody check in. All right. So let's look at it. Wow, that's awesome. 100%. So we grade that as A. And look at that, up from 82%. Yeah, 82%, that's a great starting point. That's awesome. Very nice, y'all. Very, very nice. Okay. So salt water, y'all said was a homogeneous mixture. Why? What is a homogeneous mixture? It's the same throughout. So let's talk about each one of these other ones. So you are right. Why is oil and vinegar not? What do you think of? Salad dressing. That's what I think of. I think it's salad dressing, right? I have that oil and vinegar salad dressing, and that oil sits at the very top, right? And the vinegar sits at the bottom. Okay. So what kind of a mixture is that? Heterogeneous mixture, right? How about hydrogen? Yeah, it's not a mixture, right? This is a pure substance. It's a pure substance, H2. It has a formula of H2. I write so fast, sometimes it just doesn't pick it up. All right, water. Oh, look at this. Now we have a chemical formula, right? Water is a compound, which makes it a pure substance, right? Now, when we look at H2O, What does H2O tell us? It must be 2 hydrogen atoms and 1 oxygen atom. So be careful, it's not 1 H, 2 O's. It is 2 H's and 1 O. So an oxygen with 2 hydrogens bound to it. Okay, so be careful with that. We know those subscripts are telling us the number of the atoms. So the 2 goes with the H. How many oxygens is really 1, but we just don't write the 1, right? That's understood. Okay, so we might come back to this if we have some more time, but we got to pick up where we left off on the problems, right? We were doing, how far did we get? We got to this one, but I don't think we finished it, right? We did A, yes? Right? Did we do B? No. Okay, let's do B. So, yeah, you can turn off your clicker. Okay, so Na, what is Na? Sodium, right? How many sodium atoms? 1 atom. Okay, what's my next element? Hydrogen, H for hydrogen. How many atoms? 1. What's my next element? Carbon. How many atoms? 1. My next element? Oxygen. How many atoms? 3. So it's always the subscript follows the element symbol. Okay, how about C? What do we have? Carbon. All right, that's a C, carbon. How many? 14. What's next? Hydrogen. How many? 18. What's next? Nitrogen. How many? 2. And the last one? How many? 5. Okay, so the subscript that comes after it tells us how many atoms are inside of 1 molecule of that substance, right? So in aspartame, in 1 molecule of aspartame, we have 5 atoms of oxygen, right? Now, if I put aspartame in my Diet Coke, right? I'm not just putting 1 molecule, right? I'm putting a lot. So then that would be however many molecules you would have. You might have to put a coefficient right here in front of it, and that would tell you how many of all of that you would have. Okay, we'll talk about that in a minute. So when we talk about chemistry, there are kind of 2 different things that can happen when we manipulate substances. We can change the environmental conditions around a substance, and that substance can stay the same substance. So for example, if I have ice, if I melt the ice, I'm changing the environment. Did I change the substance? No, what was the substance to start with? Water. What is it now that it's melted? Water. What if I heat it? Steam. Am I still water? Yes. So are those physical changes or chemical changes? Those are all physical changes. Now, what if I had some sugar and I put it in my pan and I turned the fire on and my sugar burned? Physical or chemical change? Chemical. What are my key things that I know it was chemical? Well, it burned, right? So it changed color. It gives off what? Have you ever smelled burnt anything? Right? You walk into somebody's house and you're like, I'm not eating here, right? Because it stinks. Burning stinks. An odor, right? It gave off an odor. Sometimes it'll give off a gas, right? Depending, but you look for those changes. Okay, so it's important to be able to tell the difference between a chemical change and a physical change. In a chemical change, we no longer have sugar in that pan. We have turned it into something different. The bonds have broken, the bonds have rearranged, and we have a new substance, right? We're never going to get sugar back after you burn it. It is over, it's done. You might even have to throw that pan away. So remember the difference between physical and chemical. Physical, the substance you started out with is still the same substance. So if I put sugar into water, is that a physical change or a chemical change? If I put sugar into water, physical, right? If I boil that substance and the water evaporates, and what am I left with at the bottom? Sugar. If I continue to heat it, then the sugar will cook and that'll be something different. But if I just heat it enough for the water to evaporate, I'll end up with sugar again, right? So we have to be able to go backwards with a physical change, like ice, right? If you let your ice melt and then you put it back in the freezer, you get ice again, right? It's no big deal. Okay, so physical, chemical. All right, so look at 1.12. We need to decide if it's going to be a physical change or a chemical reaction. Cream, sugar, and flavorings are mixed and frozen to make ice cream. Physical or chemical? Physical. Physical. I'm just going to put a P for physical. Global issue. Oh, I was like, what? No, that's an error. B, milk spoils and becomes sour. That's chemical. That is chemical, right? It smells awful. It tastes even more awful, right? You're never gonna, now taste can be an indication that you've had a chemical change happen, but are you gonna be tasting things in a chemistry lab? Please don't. All right, a puddle of spilled nail polish remover disappears. Physical, what happened? All that was evaporation. That was it. So that is physical. So it's just if it's a state of matter change, you go from a solid to a liquid to a gas, or even a solid to a gas. That's all physical changes, right? All you're doing is changing state of matter. All right, so now one of my favorite things, balancing chemical equations. Love balancing chemical equations. All right, we're going to look first at kind of a pictorial representation of a chemical reaction, and then we're going to do it like we normally do it. So look at A. In A, we have silver spheres and red spheres, right? When we look at any given chemical reaction, right, we have stuff on the left and we have stuff on the right of the arrow. So what do we call the stuff on the left? Reactants. What do we call the stuff on the right? Products. So I'm gonna use those terms from here on out. And then that's a yield sign in the middle, right? So I'm gonna use reactants and products in my terminology from here on out. Okay, so look at the reactants. How many total atoms of silver atoms do we have? 2, right? So we have 2. In the products, how many do we have? So 2 here, and we have 1 here. If we want to balance a chemical equation, the number of atoms of each element on the product side must equal the number of atoms of that same element on the reactant side. Has to. And in the process, you may not play God, you cannot create, you cannot destroy things. Okay? So I can't look at this and go, oh, I'm just going to destroy this. Now I have 1 and 1. I'm good, right? No, I can't do that. I can't do that. That's wrong. Don't have that power. Okay. So what could I do? Yes, sir. I could. So let's talk about the grays first, though. I have 2 grays on the reactant and I have 1 in the product. If I can't take away from the reactant, what do I need to do? I need to add to the product. So I can't just add a silver atom. Like if I'm going to draw a black, that's going to be my representation of a silver atom. I can't just do that, right? I have to make more of the whole thing that's there, right? So this compound that I'm looking at is a silver atom and what? 2 red atoms, right? So that I can do. That's okay. That's allowed. So now I have equal numbers of grays on the left and the right. Do I have equal numbers of red on the left and the right? No. So on my reactant side, I have how many? 1. On product side, I have how many? Count again. Look at my new ones. I have 4. So what am I going to do? I need some more on the reactant side. So I'm going to just draw it, right? Now, do I have the same number of gray spheres on either side? Yes. Do I have the same number of red spheres on either side? Yes. Okay. Pictorially, that's what happens. But y'all, that would take a really long time to draw all the spheres and draw. We're not doing all that, right? So the easier way is to use coefficients to change the number of molecules of each of the compounds in a balanced chemical equation. So if we put a number in those blanks, those numbers are called coefficients. Okay. And when we put a coefficient there, it's like multiplication. So if we have O2, let's just say, this is oxygen. If I give a coefficient, if I put a coefficient of 3, that means that I have this O2 molecule, right, that's got 2 oxygen atoms. How many of those molecules do I now have? I have 3 molecules for a total of how many oxygen atoms? 6. So 3 times 2 is 6. So that's how the coefficient works. Does that make sense? So what coefficient should we put in front of the first reactant, the gray spheres? Nothing, but nothing really means 1. But we typically don't put it. We just leave it blank, okay? How about the second reactant, the red one? 4, because if there's nothing there, it really means 1, right? So 4 times 1 is 4, so I have 4, okay. How about my product? 2, very good. Okay, now I'm gonna look at these spheres and I'm gonna convert this to a normal balanced chemical equation like you normally look at. I'm gonna call these gray things X's, if I could. I'm gonna call those X atoms. I'm gonna call the red ones Y atoms. I did that wrong. Haha. These are Y's. Come on, Dr. B. Okay, so now, how would I write the chemical formula for the gray molecule? X with a subscript 2, right? Because in this molecule, I'm saying I have 2 atoms of X, right? Okay, how do I write the formula for the second reactant? Just a Y, but there's no subscript. It just means 1. Okay, how do I write the formula for my product? Be careful. The subscript goes behind the element. So we'll say it is X, Y2. Now I want to go in and add those coefficients, right? So for X, for the first reactant, X2, what do I put? Nothing, which is really a 1, right? Plus my Y, what do I put in front of the Y? A 4, yields 2XY2. Okay, make sense? Yeah, okay. So now let's look at the bottom. What should my coefficients be? Give it a minute, just look. You do it. What should my coefficients be? Give everybody a minute. What should my coefficients be? 1s across the board, right? Because if I look, the dark gray spheres, how many do I have in the reactants? I have 1. How many in the products? 1. How many light gray in the reactant? 1. How many light gray in the product? How many red in the reactant? 1. How many in the product? How many green in the reactant? How many green in the product? 1. Right? So what if I called this A and B and C and D. Okay, so it would be AB plus CD yields AC plus BD. Right? That's all we're doing. Okay. All right. So y'all want to try some real ones? Let's try some real ones. But sometimes it's nice to look at things that way. Now I messed up. I should have left y'all a ton of room here and I didn't. So what I'm going to do is I'm going to go to the bottom of the page and rewrite the problems because I can only extend at the bottom of pages. Okay. Then I'll scroll back up. Okay. So I gotta go back and look at my paper. What do we got? Okay. So I got A, NO2. Now, what is that little G after the NO2? Tells me it's a gas, but I'm not going to write it just because we don't really care about it right now, and it'll be a little bit cleaner to look at. So plus H2O, what does the L mean? Liquid, yields HNO3 plus NO. I should have left myself a little bit more room there. Okay. So can I give you a hint? If you see the same element in multiple compounds, balance that one last. So who do you want to balance last? Oxygen. I want to balance oxygen last. So let's tackle the other ones first. Which one we want to start with? I personally want to start with, I like starting with the one that's only in one in each. Doesn't really matter. But hydrogen, how about hydrogen? So in our reactants, how many hydrogens do we have? I have 2 because the 2 is behind the hydrogen. So I have 2. Okay, how many in the products? 1. Can I take away anything? No, I can just make more molecules. So I want to make more of my reactant NO3, excuse me. So what do? I'm going to put a coefficient of 2 in front of the molecule. Now, what does that mean? I have 1 hydrogen atom per molecule, but I have 2 molecules. So that's 2 times 1 is 2. Okay, so now those balance. What else do I need to look at? Nitrogen. So in my reactants, how many do I have? 1. In my product, 2, because you have this coefficient, and then really there's nothing there, so it's really a 1. I'm not really going to show that, right? So 2 times 1 is 2. So what do? Okay, so I have another nitrogen here. So what do? 2 plus 1 is 3. Good. Okay, so now what do? Put a 3 in front of the NO2. Let me do that in black. So it's kind of easy to see. A 3 here. So now I have 1 nitrogen atom in this molecule, but I have 3 molecules. So I'm going to say 1 times 3 is what? 3. Okay. Now what? I need to do my oxygens, right? Okay, so oxygen, 3 times 2. Good, good, good. Where did you get the plus 1? From the oxygen and water. So what do I have? 3 times 2 is 6 plus 1, 7. Okay, and then my oxygen on this side, I have 2 times 3, which is 6 plus 1 from NO gives me 7. So am I balanced? Yes. Okay. Now you don't have to show me all the work at the bottom, but that's just so you can kind of follow along. Okay. Good. All right. Now B. What do we got? NH3 plus O2 yields, excuse me, N2 plus H2O. Okay. What do we want to start with? Nitrogen? Okay. So nitrogen, how many on reactants? 1. Nitrogen, how many in products? 2. What are we going to do? Put a coefficient of 2 in front of the NH3. So 1 times 2 is 2. Okay. Now what? Hydrogens. Okay. How many do we have on the left? 2 times 3 is 6. How many do we have on the right? So what do we do? So we're going to put a 3. What do we get? Okay, now what? How many do we have in the reactants? How many do we have on the products? 3. Okay, what do we do? If I multiply the reactant by 3, I'm going to get 6. If I multiply oxygen, what am I going to do?
Could you like double this, right? The water.
Double the water. Okay, so if we double the water, wait. If we double the water, there's 3 times 2 is 6.
Go back to the first one where it's 2, and then put 4,
And put a 4 there.
and then from there keep the 3 for the oxygen, and then just put a 2.
Okay, so let's check to see if she's right. So let's check. Let's start with our nitrogen. Look at nitrogen. How many nitrogens do I have? 1 times now what? 4. What do I get? 4. Okay, on the product side, 2 times 2 is 4. Okay, now let's look at hydrogens. Reactant, how many do we have? 4 times 3, right? Not 2 times 3, we have 4 times 3, and what do we get? 4, 8, 12, right? Okay, hydrogen on the product side, 6 times 2, right? So 6 times 2 is 12. Then oxygens, I'm still doing 3 times 2. Oxygen, now I'm doing what? Just 6 times 1, right? Does it check out? Yes. Good. So sometimes what you have to do is look and see like your hydrogens on either side. If you look at your hydrogens, hydrogen is 3 on the reactant as a subscript, and hydrogen is 2 as a subscript on the product. I know that I'm going to have to multiply by some number to make that work out, right? You're going to have to keep multiplying. Now, one thing I do want to tell you, what if you got coefficients of, let's do this. What if you got coefficients that were 8, 6, 4, and 12? You have to simplify. So the whole definition of a balanced chemical equation is the smallest ratio of the substances. So what are all these divisible by? 2. So if I divide them all by 2, I get my coefficients. So like if you don't get quite the right answer, right? Double check, make sure, do I need to reduce? And sometimes that's where your issue is. You just need to reduce. Okay. C. Let's see. Okay. What do we got? C7H16 plus O2 yields CO2 plus H2O. Who do you not want to start with? Who do you not want to start with? Oxygen. So don't start with oxygen. Who do we want to start with? Carbon, sure. Carbon, how many on the reactant side? How many on the product? What do we do? put a 7, so that's 1 times 7 is 7. Okay, now what? Don't do oxygen. We're gonna do, let's look at hydrogens. How many on the reactant side? 16. Hydrogen, how many on the product side? 2. How do I make that work? An 8. Okay, now what? What do we have? So we have 8 plus, I guess I could do it the other way. I would do it the other way. Okay, so 7 times 2 is 14 plus 8. What do we get? 22. So how do we make 2 equal 22? Times 11. Oh, that's not right. 11. 11. Okay. Now, some people need more practice with this, right? So I put a tutorial up on Moodle right under the chapter 1 material, and it gives you some more practice. So I gave you like, it's basically like some more problems and space to work them in. So you try it, then watch the tutorial. See if you can do it on your own, right? Okay. I got to scroll back up, right? So I did all this. Okay, so that was 1.16. All right, now, when we do science, we don't just use numbers, right? We use numbers with units, and our numbers have limitations. And we have to understand what the limitations of those numbers are. So depending on what kind of tool you use to make your measurement, will tell you what kind of precision your numbers have. So generally, if you were looking at like a ruler, right? How precise that is depends on how many of those little tick marks you have, right? The more tick marks you have, the more precise your answer can be. So in science, it is super important to keep track of that precision. And the way that we do that is we use what are called significant figures, or as I like to call them, sig figs. Just sounds cooler, right? Just does. So there, if you watch the lecture, you should have watched the lecture. You watched the lecture, right? There are a ton of rules, right? There are a ton of rules. I could sit here and tell you to memorize rules, but that's not even how I do it. When I look at numbers, I'm going to teach you the little trick I use. So I've found this great picture of the United States, so I wouldn't have to draw it because I'm a horrible drawer. So I was pretty excited to find that. So what I like to keep in mind is everybody likes the US, right? And everybody's trying to get into the US, right? Now I have to recall a little bit of geography. We were actually, I'm studying this with my son. He had a test yesterday on the continents and the oceans. It's kind of funny. So what ocean is on the left-hand side? The Pacific Ocean, so that's why I have a P here, P for Pacific. And then what's on the other side? Atlantic, that's A for Atlantic. So if you keep this picture in your mind, the P represents, if you have a number and the decimal is present, you're going to use that arrow that points into the United States. If your decimal is absent, you're going to use an arrow, but you're going to use the arrow that goes the other direction. Okay? So when you do this, you give any given number, you determine is the decimal present or absent. Look at A. Is the decimal present or absent in A? In A, I'm sorry, 1.18. It is present. It is present. So what I'm going to do is I'm going to take my arrow and I'm going to cross out zeros until I get to my first non-zero number. Everything after that is significant. Okay, so I take my arrow, I cross out zeros until I get to my first non-zero digit. That's a 6. Everything behind the 6 is significant. So how many significant figures? 2 SF. Isn't that easy? Okay, look at the next one. Decimal present or absent? Absent. So now I'm coming from this side of the United States, but I still want to get in, right? So I'm going to use my arrow And I'm going to cross out zeros until I get to my first non-zero number. How many significant figures?
1.
Okay. C, decimal present or absent? Absent. So I'm going to cross out zeros coming from the Atlantic side of the US. How many significant figures? Isn't this a nice trick? D, present or absent? So which way do I come in from? The Pacific Ocean. I stop at my first non-zero number. Did I have any zeros to cross out? No. So how many significant figures? 4. These 2 zeros are significant. So you have to put them. That's 4 significant figures. That means that somebody measured length and they said it's not 25.56, it's really 25.00. They did that measurement. And so you have to keep those zeros. Okay. All right. So now, when we add, subtract, and multiply and divide, when we do math, science math, I love science math. It's the best kind of math. You have to keep track of that significance. When we calculate something based on multiple numbers, our final answer cannot be more precise than what we started with, right? I can't measure a length being 25.00 meters and then say, well, how much of that 25.00 meters did the car go? Well, it went 5.6732 meters. That doesn't make sense because my meter stick won't measure that kind of a precision, right? So my answer can't be any more significant than my least significant initial value. That's a big wad of words, right? So let's see what that means, right? Look at A. How many significant figures did I have in A? In 100, I had 1 significant figure, and in 23, I had 2. So which one is least significant? Having 1. So my final answer can only have 1 significant figure, and you have to round it to make that happen. Okay. So if you are multiplying or dividing, these are our rules to live by. If we multiply or divide, our final answer has the same number of significant figures as the least initial significant figures, right? The least. But the same is not true if we add or subtract. Because when we add or subtract, you have to be careful of the place value. So when we add or subtract, our final answer, I know I really can't spell it. I think it's just my brain goes too fast and it always ends up being spelled wrong. Okay, so final answer has the same number. It's not of significant figures in this case. It's now places past the decimal as the least initial, right? So look at B. How many places past the decimal in 97.5? 1. How many in 43.02? 2. So what's my final answer going to have? 1 place past the decimal. Okay, so let's go do some practice. You ready? Okay, so in A for 1.20, which one has the least number of significant figures? They have the same number. They both have 2. They both have 2 significant figures. So if you put that into your calculator, what value do you get? I want to know exactly what you get in your calculator. So put it into your calculator. I love y'all. Y'all don't know this about me, but one of my favorite sounds in the world is the clicking of multiple calculators in my classroom. It's beautiful. So I want to hear all the calculators clicking, all of them. I feel like she's so weird. What do you get? 3.5416 repeating. Okay. Can I put that on the test? You, Dr. B is gonna mark it wrong. So what should my final answer really be? 3.5, because here are my two significant digits. Then I have to look behind the last one for rounding. So if it's a 5 or above, that 5 would round up to a 6, right? Okay, look at the next one. Are we counting significant figures in the next one? No, we're looking at places past the decimal. So how many places past the decimal should my final answer be? 1 place past the decimal, because 43.0 only has 1 place past the decimal. So put it in your calculator. What do you get? So I can only have 1 place past the decimal. So that will give me a final answer of, good. All right, I'm going to kind of come down here with this one. Am I looking at significant figures or places past the decimal? Significant figures. So I multiply the two. Which one has the lowest number of significant figures? They both have the same. They both have 2. So what do I get in my calculator? Okay, and what does that round to? Be careful. Those are your 2 significant figures. Look behind it. 7.2. Okay, and then I guess I'm going to have to, I'll do this one up here. Okay, so what am I looking at? Sig figs or places past the decimal? Places past the decimal. How many are going to be in my final answer? 3. What do you get in the calculator? And when I round that with 3 places past the decimal, what do I get? Yes. Okay. Now, the next thing we're going to talk about is converting units, right? Remember how I said that probe crashed and burned because we didn't convert units properly? Converting units is so hugely important, but I think it's kind of intimidating for y'all sometimes. So I want to talk about this with some units that you already know. So if I said that sitting in my refrigerator right now, I have 24 eggs, right? How many dozen eggs do I have in my refrigerator? 2. Okay, we already know the answer to it. So from here on out, whenever we have to change units, we're going to use what's called, maybe you called it dimensional analysis. Maybe you called it the factor label method in high school. Do y'all remember this? I like to call it fence posts. We're going to do this the easy way, right? So here's my line, and then I'm going to put me a fence post. And as we go on, we'll have to have more and more fence posts. But for right now, we're only going to have 1. So what I want to do in a unit conversion is to get rid of 1 unit and introduce a new one. But to do that, I have to have an equivalent relationship. So what equivalent relationship did you use in your mind without even thinking about it? 12 eggs is equal to what? 1 dozen. This is the equivalent relationship that you need. So in math, if you have something in the numerator and something in the denominator, and those 2 things are equal, what happens? Like if I have 5 divided by 5, what happens? They cancel, and what do I end up with? 1. Okay, same thing with units. If I have eggs in the numerator and I want to get rid of eggs, where do I put eggs? In the denominator. Now I'm going to put my other unit in the opposite place, right? It won't always be eggs on the bottom, but I'm going to put the one I want to introduce on the opposite place. So I'm going to put dozen eggs up here, right? So my eggs cancel and I'll be left with dozen. So now all you have to do is go back to your equivalent relationship and pull the numbers out. So how many eggs? 12 in how many dozen? 1. So I get an answer of 2 what? Dozen. Now in science, I don't want to see a number that doesn't have a unit. A number without a unit is meaningless, completely meaningless. Okay, so now let's use this fence post method from now on. Okay, I'm gonna erase it. We're gonna do number 1.22 because I know it looks like I've written all over this, but this is what we want to do. Okay, on average, an adult's lung volume is 5 liters. Convert to milliliters. Okay. Do you have to memorize all kinds of unit conversions and stuff? Who's your best friend? Exam resources are your best friend. So if you pull this up either on Moodle or you have it printed out, I would highly recommend printing it out just so that you can keep going back to it. Right in the middle are metric prefixes. So what metric prefix are we using in this problem? What? Milla is the prefix, right? The base unit is the liter, but milli. So what is M? M is milli, right? So if you look at that unit prefix, what is milli? It's 1,000. Okay, so I need that equivalent relationship. I want to convert between liters and milliliters. If I want to make a statement like this, but using milliliters and liters, what would I write? One liter is equal to 1,000 milliliters. Once you can write this, the fence posts are really easy. So what am I starting with? 5 liters, right? 5 liters. Put my fence posts up. If I want to remove liters, where do I put liters? At the bottom. What do I put on the top? Now, what value goes in front of milliliters? 1 or 1,000? Look at your equivalent relationship. What goes with milliliters? 1,000. What goes with liters? 1. What do I get? 5,000 milliliters. Now that one was really easy, but trust me, we are going to build up to way more. Okay, it's important that you get the base. Okay, all right. So a lot of times when we get really big and really small numbers in science, it's kind of wasteful to write them that way. So we use scientific notation, right? And in scientific notation, the standard format is that we have a number that is between 1 and 10 multiplied by 10 raised to a power, right? And it shortens how we write numbers. So if I want to do this, what I do for A here, 1.24, I'm going to look at this number. If I wanted to write this number, but make it to where it was between 1 and 10, and all I can do is move the decimal point, what number do I get? 1.4, right? So where was my decimal place to start with? Right behind that last 0. So now if I want to know that's 1.4 times 10 to something, all I have to do is count the number of times my decimal place has moved. 1, 2, 3, 4, 5, 6 to get to that final destination. So that makes my exponent 6. The only question is that a positive 6 or a negative 6? Positive. If that number is big, if it's greater than 1, it's going to be positive. If it's really small, it's going to be negative. Okay, it's all about how the direction that decimal place moves. So look at B. If I want to rewrite this number, and all I can do is move the decimal place to make it between 1 and 10, what number do I get? 7.9. Now we're going to do times 10 to the something. So I'm going to take my decimal and I'm going to move it. But what am I doing? I'm moving in the opposite direction. That tells me that my sign's going to change. So I move it 1, 2 times, -2. Okay. Look at C. What number would I get if all I do is move the decimal to get a number between 1 and 10? Times 10 to the -6. So let's count. 1, 2, 3, 4, 5, 6. Y'all are right. Okay. All right, you got to go back and forth. So you also need to be able to start with scientific notation and convert to standard notation. So what do I do? The exponent tells me the number of times my decimal place moves. If it's negative, you should end up with a number that is less than 1. So what direction is my decimal going to move? Left, 1, 2 times. So I'll end up with 0.074. If you have a negative exponent, the trick is the number of zeros between the decimal and the first non-zero number is 1 less. So if it's -2, I have 1 0. Okay. 3.75 times 10 to the third. Which direction is my, I'm going to move to the right 3 times. 1, 2, 3. So that would be 3750, 3,750. Last one. Go over here. -8. So then I'm going to put 0. How many zeros do I need? 7. 1, 2, 3, 4, 5, 6, 7, 1, 1, 9. Not too bad, right? Got that. Okay. Express the following numbers in decimal form. An asthma medication of 1.00 times 10 to the -8. What should it be? Good. Well, I need those 2 zeros because when you convert between different forms, your number of significant figures should never change. How many significant figures were in my original number? So my decimals present or absent? Present. So I come in from this direction. There's my 1. Everything after is significant. So how many significant figures? How many? 3. Same thing here. My decimals present or absent? Present. So I come in from this direction. How many significant figures? Only 1. So I need to put in my 2 zeros. I'm missing something else too. And y'all, maths need to be up over noses, please. Grams, because a number without a unit is meaningless. Y'all are gonna go home and like chant that, right? Okay, B. What should my answer be? 1, 2, 3, 4, 5. Yes, awesome. Good. Okay. All right, now there are other forms that we have to be able to switch between. A lot of times we have to switch between decimal format and percent. So if I have something in a decimal format, right, how do I get that to a percent? I multiply by 100. So what do I get? Did my final answer have the same number of significant figures as my original value? Yes, you should always check that. So B, same thing, just multiply by 100. What do you get? 36%. Multiplying by 100 is just moving the decimal place twice. That's all it is. Multiply by 100, what do you get? 12.5%. Okay. Now, sometimes you also have to be able to express it as a fraction. So 200% is another way to write that. If I wanted to convert between a decimal to get to a percent, I multiply by 100. So what should I do to go the other way? Divide. So really that's 20 divided by 100. You could get the decimal form just by pressing enter on your calculator, right? But I don't want that. I want it as a fraction. So what do? cancel my simplify. So cancel out my zeros. 2 divided by 10, 1/5. Okay. How about 75? 75 divided by 100, 3/4, right? Because they're both divisible by 25. Okay. C, we'll do C kind of over here. 40 divided by 100. Cross out my zeros. Simplify. What's that? 2/5. Okay, and then the last one, 12 divided by 100. What do we get? Good. All right, not too bad. Sometimes you have to convert and figure out what percent of something, right? So we're going to try and determine the percent from a given number. So whenever we're reading a problem, anytime you see is, what does is mean? Equals. So 50 equals some percent, and you're going to put that over 100, right? Of 125. Right? It's multiplied. Yes, it's multiplied. So now you're going to solve for X. I don't know how y'all solve for X. There are multiple ways to solve for X. What do y'all like to do? I'll tell you what I do. If I want to get X by itself, right? X is being divided by 100. So what am I going to do? Multiply by 100. And X is being multiplied by 125. So I'm going to divide by 125. What I do to one side, I have to do to the other. So my hundreds cancel, my 125 cancels. So X is equal to 100 times 50 divided by 125. Yes? Do y'all do it that way? No. You could cross multiply, whatever algebra you like to do is cool. It doesn't matter to me. So what do you get? 40%. Good. Okay, B. 6 is what percent, so that's X out of 100, of 600. Solve for X. However you like to solve for X. Don't like to impose my ways on anyone. What do you get? I do it not 10. 600 cancels, 100 cancels. You do 100 over 600. So 100 times 6 is 600 divided by 600. What do you get? 1. However you like to do that. Okay, C. What percent of 300 is 15? So we have something over 100. What percent of 300 is equal to 15? Right? It just got rearranged. It's the same sort of deal. It just got rearranged. So this is my method. But you do your method. It's cool. What do you get? What? Okay. D. D is what percent of 400 is 30? So some percent of 400 is 30. What do you get? Like you're in math class again, right? What do you get? Throw it out there. That's what I got, 7.5%. All right. So now we get into like math and science. It's awesome. That was just math. That was like your math review. Now we get into math and science. So remember when we were talking about last time, we talked about density, right? So based on our experiences in life, what happens when you drop a paper clip into water? What will it do? Sink or float? Sink. It will sink. Try it at home. A paper clip will sink. So if the paper clip sinks, what does that tell me about the density of that paper clip? It's more than water. So it's more than liquid water. Okay. How about table sugar? It will sink. Y'all, this brings me flashbacks to when I was a kid, right? That was before the no sugar Kool-Aid. We used to get the Kool-Aid packets, but it was really small packets because it was just the flavor. It was just the red number 5. And then you had to get the sugar out, and then you had to scoop out. It was like cups worth of sugar. It's terrible. And what would happen? All that sugar would just go straight to the bottom. You'd have to stir it, right? So that it would dissolve. So what does sugar do? Sinks. So it is more or less dense. More. How about ice? It will float, so it must be less. I know that y'all see that every single day, right? You have a glass of water with ice. Maybe not every day, but y'all have no idea how unbelievable that is. Most substances, when you go from a liquid form to a solid form, it becomes more dense. Water becomes less dense. Only substance to do that. It's amazing. I'm going to teach you why it's amazing, but not today. I will teach you. It is amazing. You should look at it and think this is awesome. Okay. So now we talked about density, right? You remember your density formula from yesterday? You know what I like to say? If I'm calculating density, I better go to the DMV, right? Because density is equal to mass over volume. But when we do that, what are our units on mass and volume? Grams per milliliter. So if I'm given a problem like this, where I'm asked to calculate density in grams per milliliter, and I'm given a value, 2.0 liters of gasoline. Am I in the right unit? Oh no. And that gasoline now weighs 1.32 kilograms. Am I in the right unit? I am not in the right unit. So what am I going to have to do? Convert. I need to convert. So I'm going to have to do 2 conversions. I'm going to have to convert from liters to milliliters, and I'm going to have to convert from kilograms to grams. Okay, so let's kind of do that down here. We have 2.0 liters. Put your fence posts. What do I want to get rid of? Liters. So I'll put liters on the bottom. What do I want on the top? What's my relationship? What's my equality relationship? 1,000 milliliters is equal to 1 liter. So what goes in the milliliters? 1,000. What goes with the liters? So what do I get? 2,000 milliliters. Okay, that's one of them. Now what do I want to do? Convert my mass. I have 1.32 kilograms. I want to get rid of kilograms. So where does kilograms go? At the bottom. What goes on the top? What's my equivalent relationship? 1,000 grams is equal to 1 kilogram. Remember, a kilogram is big, like 2.2 pounds per kilogram, right? And gram is pretty small, pretty small. So I have 1,000 grams in 1 kilogram. So what do I get? 1,320 grams. Now those masks need to stay on over your mouths and your nose at all times. Okay. All right. So now we can come back and we can plug this into our formula. So what's my mass? What's my volume? What's my final density? Units? Grams per milliliter. Now, I'll tell you a secret. This one you could have done without the conversion and it would have worked out, but it doesn't usually. Okay, because you did each one to get each conversion, you multiply both by 1,000. So you did the same thing to both. So it would have worked out, but trust me, it won't happen like that on a test. Okay, so I'm just trying to help you out, get you going in the right direction. Okay, now, did I tell this story about, I did tell the story to this class about the misstep in conversions from the US. Did I tell you the story? No, okay. So I forget. So we were doing a joint NASA mission. And when we do math here in the United States, what system of units do we use? We use English. What does everybody else use? Everyone else uses metric. Everyone. So NASA was doing some calculations. They did them in English, and we were doing this joint mission with the European Space Agency. And guess what they did their calculations in? Metric. We combined information and we launched a probe to Mars. Guess what? We didn't convert to metric before we gave them the data. So when that probe got to Mars, instead of orbiting Mars and taking lots of great pictures, it burned up in the atmosphere of Mars. You know how much money went down the toilet? That was insane because we didn't convert things. So our conversion is important. Like, yeah, it's really important. So one of the other conversions that you need are temperature conversions. Like if you told somebody from Europe that it's 100 degrees out today, they would flip. They'd be like, no, it's not. You're not dying, right? Literally. So it's important that you're able to convert. So you need to pull it up because there are multiple formulas for temperature. So here we have fetal cord blood that's stored at negative 112 degrees Fahrenheit. What if you have a freezer, but it's not in Fahrenheit, it's in Kelvin? How do you know what temperature to set the freezer at? You have to be able to convert, right? So look on your thing. Do we have a formula that will convert us straight from Fahrenheit to Kelvin? No. So we're going to have to go from Fahrenheit to Celsius to Kelvin. Okay, so let's do the first one. Let's do Fahrenheit to Kelvin. Which formula do I want to use? If you're looking on your sheet, is it the top one or the bottom one? I want the bottom one because it gives me degrees Celsius, right? Degrees Celsius equals, and I'm going to do all the math. Degrees Fahrenheit minus 32 times 1 over 1.8, right? So plug in degrees Fahrenheit, that's negative 112 minus 32. What do we get? Just do the subtraction. Let's simplify. So negative 112 minus 32, negative 144, that's still degrees Fahrenheit, times 1 degree over 1.8 degrees Fahrenheit, right? Celsius. So then what happens? Our Fahrenheit cancels, We're left with Celsius. So negative 144 divided by 1.8, what do we get? What? Negative 80 degrees. Now what do we do? Now I need to go get my other formula where it says Kelvin is equal to degrees Celsius plus 273. So Kelvin is equal to negative 80 plus 273. What do you get? (193 Kelvin). Okay. So make this your best friend. So it looks like we are so not finished with the first chapter. So I'm going to move the homework. I'll move it this afternoon. So it was going to be due Monday night. So then it'll be due Wednesday night. Okay. So I'll get online and I'll move it tonight. What do you mean? Where do I find the homework at? It's in Moodle. So you go to course materials. And when you click the course materials, it brings you to the Pearson website.
Okay.
Yep. Yep.